Hi, my name is Serge Amé. I'm the president of the Planet Mars Baking Society non-profit, and I intend to open the first bakery on planet Mars. If the predictions of Elon Musk materialize, there will be one day 1 million people living on that planet, and if I would be the only baker there, I'm sure to make a lot of dough. Anyhow, if we are serious about colonizing planet Mars and possibly other planets in the future, one of the important hurdles to tackle is to develop a sustainable agriculture on such planets. Imagine what would happen if by accident the supply ship disappears and the Martians are left to themselves. They would perish unless they can feed themselves. Another reason is the cost of shipping food to the faraway planet. Such cost is horrendous. For a colony of 1 million humans, one talks of billions of dollars per year. Therefore, if we can develop a staple crop, those figures could be substantially reduced. Mars is the closest to Earth of all potentially habitable planets. There is water, be it under the form of ice, and a huge amount of carbon dioxide, the building stone for vegetation. Agriculture in a closed environment will be possible and less complicated than, for instance, on the space station. Not the least because on Mars we have 0.38% of the gravity of planet Earth. The staple food should be healthy and highly nutritional. Myself, I've opted for bread. Not only because it is the subject I know best, but mainly because I'm convinced it is the most complete and the most universally accepted staple food for human beings. History proves that mankind can survive for many years were it only on bread and water, though this is not really the target. To make bread, we are going to need grains. Why not wheat? Since that is the most versatile of all grains. Other than bread, one can also make pasta, porridge, and couscous out of it, or even nutritional drinks. Besides, wheat contains more nutritional elements than any of its competing staple foods, as we can see in the following slide. But what could be the ideal bread during the first phase of the colonization of planet Mars? And how can we simulate the production process? We want the most nutritious bread recipe possible and at the same time the easiest to produce. My formulation consists of only crushed wheat seeds and hemp seeds mixed with water and fermented by bacteria. In this case, the Lactobacillus sanfranciscensis, which is the famous San Francisco sourdough bread bacillus. This culture was provided by Paratus Group. An alternative can be to mill the seeds with a small stone milling device and use the whole wheat flour. Note, in my recipe there is no yeast, no salt, no sugar, nor any fat added. Simpler is not possible. In the first phase of exploration on Mars, crews will be pretty small. So to keep things simple, I dared to crush the grains with a standard kitchen food processor. Later stone milling with basalt stones will be possible. I added hemp seeds to make the bread a complete diet. Hemp will grow well in the hydroponic habitat. Those seeds contain up to 32% of precious omega-3 and omega-6 fats, marvelously completing the diet. The fiber of crushed wheat and the fiber of hemp are excellent prebiotics, stimulating the digestive flora in our bowels. Hemp, also known as cannabis sativa, contains minor amounts of THC, which is nowadays considered to have an excellent impact on bone health. A major issue in a low gravitation environment. Hemp will be a great crop culture in the future, both on planet Earth and as well on Mars. On Mars, not only for the nutritional quality, but also for producing textile, plastic, and even building material. Altogether, this is quite essential for a future self-sustaining economy on Mars. Now, for the production of a bread for Mars, Here is what I suggest. The result is a palatable bread, which resembles the traditional breads made in Scandinavia, the Baltics, Russia, Poland, or in the north of Germany. 3 portions of whole wheat bread per day are recommended by the European Food Information Council. We know that. The average diet on planet Earth calls for 2000 calories per day for an average adult person. However, in space, diets vary from 2000 to 3500 calories. And those range for tinier females to real big guys. These high calorific diets are due to the 2 or 3 hours workouts those astronauts make every day. And those are necessary to prevent muscle and bone decay, which is caused by the microgravity. Now, my suggested diet corresponds to some 80% of the nutritional needs of those astronauts, and the remaining 20% will be provided by vegetables under the form of soups or salads, and also of fresh fruit, which will come from the hydroponic farm on Mars. Still, we are missing something, that is enough calcium. By serving 150 grams of Chinese cabbage, also called Brassica rapa, under the form of either a salad or a soup, or you could even mix it into the bread, this will make up for the lack of calcium. Chinese cabbage is called the king of calcium. It is also at the same time a very good source of vitamin C. Now, you will all have noticed that this diet is purely vegetarian. And that could be a reason for some to question the value of it. But wait. This diet corresponds, believe it or not, for 100% to the one Roman gladiators were fed with. And those were strong, healthy athletes. Yes, of course, healthy for as long as they didn't die in the arena. Bread was the staple food of the Roman world. In fact, the whole Roman civilization turned around bread. Even so that each Roman citizen was entitled to 1 kilogram of unmilled whole wheat bread per day for free, and that from the 2nd century AD onwards. Hence comes the famous expression panem et circenses, bread and games. And when it comes to that, we all know that the most famous of those games were the gladiator fights. Thanks to the research of Dr. Fabian Kranz of the medical faculty of the University of Vienna and his colleagues of the University of Bern in Switzerland, we have today excellent information on the diet of Roman gladiators. They did that by analyzing the bones found in a graveyard for gladiators, which was found near the town of Ephesus in Turkey. They could determine that gladiators were vegetarians with an extraordinarily strong skeleton. One could suppose that they did not receive meat or fish because those were too expensive. But nothing is less true. Gladiators were of an enormous value to their owners. And like in today's top racing horses, which will get the best and the most expensive care, so it was for gladiators. Because gladiators consumed enormous amounts of carbohydrates, the researchers concluded that they must have been carrying a thick layer of fat all over their body. I do question this, and take as proof the strongest man in the world, Patrick Baboubian. Patrick is since many years a vegetarian, even a veganist. We do definitely not notice a thick fat layer on his body of fat. In my opinion, he looks like how we imagine gladiators would have looked like. And Patrick is not alone. Several of the strongest men on earth are vegetarians. Anyhow, gladiators may have consumed up to 10,000 calories a day or more because of their intensive training. So they got rid of all the excess. They didn't have that much fat. The scientists also found out that gladiators received daily a magic potion. What was it? The magic potion consisted out of ashes mixed in a fermented drink, which the scientists took for vinegar. We know that when you expose wine, it rapidly turns into vinegar if you have it in the open air. I assume that they rather drank a young, unfiltered wine, and that is also a good probiotic. The Romans knew that to fertilize a soil, they had to burn everything on the land and then plow the remaining ashes into the soil. By analogy, they assumed that adding minerals to the diet of athletes would fortify them. And indeed it does, provided one adds a strong probiotic to digest it, and that allows the body to absorb all those good minerals. In the Martian diet, I also foresee a magic potion. It is called kvass. What is kvass? Kvass is made by fermenting either rye or wheat bread in water. It can be extra flavored with strawberries or other fruit or herbs such as mint. It is a non-alcoholic drink that is extremely rich in vitamins and in lactic acid and has a bounty of microorganisms. In other words, it is a super probiotic. To make bread on planet Mars, we will grow wheat. The question is, will that work? Yes, of course it will work. We know that because the Soviets grew wheat in space way back in their Mir and Bio 3 experiments. And so did the Americans in their NASA program called CELS. The experiments were done under zero gravity conditions. So we can claim with total certainty that within a closed environment on planet Mars, wheat will grow. To simulate this process as closely as possible, and by varying the conditions, we will try to find the most optimal conditions for providing repeatedly successful crops. For those experiments, 3 reefer containers are presently being assembled. All 3 will be hermetically closed, and an entry will be foreseen via an airlock. One container will accommodate a biohabitat in which to grow wheat under those fully controlled conditions, such as light, air pressure, even air displacement, which is wind, fertilizer, moist, and so on. Cameras and sensors will be linked to computers for monitoring all of this. A second container will accommodate a fully equipped bakery and laboratory for analysis. The third container will consist of an airlock, lockers for clothes, and sanitary facilities. This hardware is being supplied by Urban Crop Solutions and will be purchased by Paratus Group in order to be installed on their premises of their headquarters near Brussels, Belgium. The first test at the laboratories of Urban Crop Solutions indicated that their process is working. Though we must admit that a number of improvements are waiting for us. We are in the middle now of selecting several wheat varieties. One to be retained is durum wheat because it makes very tasteful bread and allows also to make pasta and couscous. It would also help to make our story on the Roman gladiators even better. Our experiments should definitely include apogee as a variety of wheat because it was used by the Soviets in their experiments in space and after that also by the Americans. Now we're going to select the best possible substrate. But the substrate is the product in which that you will put seeds and that will allow roots to start growing. And at the moment we use a substrate that is made out of the fiber of coconut shells, and that works well. It's a commercial existing substrate. But gradually we want to shift to substrates that can be produced on Mars, but there are no coconut trees there. And for that we could use the hemp. We hope to succeed in having 3 crops a year in a closed environment as opposed to a single crop in the open air conditions. And each crop will be thoroughly analyzed as to the morphology and will then following be tried in baking tests. A real innovation will be the control of the fermentation process, and that will happen from a distance via a chip capable of counting the bacteria present in the sourdough culture. And that will indicate when a new culture needs to be started, when there has been contamination. And the chip that is monitored by the computers will tell us when that has to happen. This is all about artificial intelligence, of course. Now, air management is going to be one of the most serious issues. Well, the technique for supplying humans with oxygen and disposing of the carbon dioxide that they are exhaling is since long known. It was used in submarines and today it is used in spaceships. However, we have a supplementary problem, or maybe rather an opportunity. Growing wheat produces important amounts of oxygen, and that can be used to supply the astronauts present in the bakery. Moreover, the wheat can also absorb the carbon dioxide exhaled by those astronaut bakers. Unfortunately, till now, there is no system that can manage a good exchange flow between those two components. I must say that within the MELISA project of the European Space Agency, a device is being developed for this. Hopefully, we will one day be able to use it. Or, who knows, we may be lucky and discover ourselves a solution. In parallel with these experiments, we plan also to prepare for a later quantum jump, and that will be by introducing the concept of a large automated biogenerator, and that system we call Labios. As we'll see, we see it on a picture. Labios will allow to feed the seeds and at the same time to harvest a crop in a fully automated manner within a closed habitat and without the manipulation of any humans. Everything will be manipulated via the computers. Labios, as projected, should allow to produce enough wheat to feed a crew of 6 Martians and at the same time produce the oxygen they need. The total surface of the first Labios we are going to have is 240 cubic meters. Hopefully it will be operational by the middle of 2019. By then I will be able to report back to you the results of our experiments. Goodbye for now.